So let's just see the example number 1. Example number 1 says factorize the given quadratic polynomial by splitting the middle term and by using the factor theorem. So we are applying two methods over here on this particular polynomial, and we are factorizing this polynomial by using the splitting the middle term method as well as by using the factor theorem. So let us suppose we are starting with splitting the middle term method first. So using by splitting the middle term method, let's just take the two numbers. Let P and Q be the two terms such that B can be expressed as P plus of Q, and further P into Q should be is equal to AC. As per the splitting term middle method, it says that B can be expressed as the sum of the two terms whose product is actually is equal to AC. So from splitting the middle term, we have deducted this particular concept. So let us suppose we are talking about what is A, B and C over here. So as we have the polynomial as 6x square plus of 17x plus of 5. So let us suppose we are taking the general form of this as ax square plus of bx plus of c. Now compare both of these terms, we can see that the value of the a over here is nothing but 6. So a is nothing but 6. B is nothing but 17 and C is nothing but 5. So by comparison, we can see A is nothing but 6, B is nothing but 17 and C is nothing but 5. So using these A, B and C values in this expression, which is B is equal to P plus Q and PQ is equal to AC, what we can deduct? We can deduct that, let us suppose we are writing it as B is equal to P plus Q. So P plus Q can be written as is equal to B. The value of B is nothing but 17 and P into Q, and P into Q is nothing but is equal to AC. What is A and C? A is 6 and C is 5. So 6 into 5 is nothing but 30. Now let's just talk about any two terms by using the hit and trial method. We have to find out the two terms in such a way that P plus Q should be is equal to 17 and P into Q is nothing but is equal to 30. Now let us suppose we are talking about the second equation, which is PQ is equal to 30. So let us suppose find out the factor pairs or the pairs of the factors of the 30, that if we'll multiply any two factors, what we will get after adding them. So let us suppose I am talking about the pair of the factors of 30. So let us suppose we are finding out the pairs of the factors of 30. So let us suppose we are talking about 1 and 30. The very first pair can be 1 and 30. 1 into 30 is nothing but 30, but if we'll add both of them, that is 1 plus of 30, it will give the answer as 31. So it is not satisfying this particular condition. It means that we cannot take the pair 1 and 30. So this pair is neglected. So let's just look out for the another pair. So let us suppose we are taking 2 and 15. 2 and 15. Obviously, 2 into 15 is nothing but is equal to 30, and 2 plus 15 is equal to 17. So yes, this pair is actually satisfying this particular condition. According to which we have to take the two terms in such a way that their multiplication should be is equal to 30 and their addition is nothing but is equal to 17. So 2 and 15 is nothing but the pair of the factors of the 30 that is satisfying this particular condition. Now what we can do with this 2 and 15? So let us suppose we are taking the quadratic polynomial again that we have is 6x square plus of 17 of x plus of 5. Now we can write this particular quadratic polynomial in a very interesting manner. So let us suppose I am writing it as 6x square plus of 17. So 17 was actually the term which was B, and B can be expressed as P plus Q. So write P and Q over here in term or in place of B. So let us suppose I am taking the term P. I am taking the term P as nothing but 2 and taking the term Q as nothing but 15. So let us suppose I am taking P as 2 and Q as 15 over here. So in place of B, we can write P plus Q, and which is nothing but 2 plus of 15 of X plus of 5. So in place of B, we are writing P plus of Q. Now let's just expand this term. So this will be 6x square plus of 2 of x plus of 15 of x plus of 5. Now take two terms common. So let us suppose we are taking these two terms all together with each other, and we are taking a bracket as well. Now solve the brackets in an individual manner. So let us suppose I am solving this particular bracket. We can take 2x common out of it. So the term left out would be 3 of x plus of 1, and further we can take 5 common out of this particular bracket. So the terms that are left out is 3x plus 1 again. We can see from this particular expression that we can take 3x plus 1 common out of both of these terms. So let us suppose I am taking 3x plus 1 common out of these terms. So 3x plus 1, if it is common, then the terms that are left out is nothing but 2x plus 5. So hence at the end what we have concluded that 6x square plus of 17x plus of 5 can be factorized as 3x plus 1 into 2x plus 5. This is nothing but the factors of the given polynomial 6x square plus of 17 of x plus of 5 using the middle term splitting method. So this is all about this method. I hope all the steps are all clear to you. Always remember to take the two terms in such a way that B can be expressed as the sum of the two terms P plus Q, and their product is nothing but is equal to AC. After following these steps, you have to look out for the pairs of the factors of the multiplication of AC in such a way that they can be expressed in this particular formation. I hope all the steps are all clear to you. Now let's just find out the factors using the factor theorem, because we also have to find out the factors of this particular polynomial using the factor theorem. Now let's just find out the factors or factorize the given polynomial by the factor theorem. So first of all, write the polynomial 6x square plus of 17x plus of 5, and we have to take out the value 6 common out of this particular polynomial. Always remember, if we are using the method of factor theorem, then we always have to take a common, because the coefficient of x square should be mandatory is equal to 1. So in order to take the coefficient of x square to be 1, take 6 common out of it. So we are taking 6 common out of it. So the terms would be like x square plus of 17 by 6 of x plus of 5 by 6 plus of 5 by 6. So we can express this particular quadratic polynomial into this. So let us suppose we are talking about the factors of this particular quadratic polynomial. So let us suppose I am writing it as x minus of a into x minus of b, where a and b are nothing but the factors of this particular quadratic polynomial. So let us suppose by comparison what we can say. We can say by comparison that the product of the constant terms a and b should definitely be is equal to 5, 6, obviously, as we can say that this particular quadratic polynomial is equal to this. So if we'll expand this polynomial, the product of the constant AB should be mandatory is equal to 5 by 6. So by comparison what we can say, so let us suppose I am taking by comparison of this equation, let us suppose I'm calling it as 1 and 2. So by comparison of these two equations, what we can say that the product of AB, the product of the constant AB should be mandatory is equal to 5 by 6. Should be mandatory is equal to 5 by 6. Now let's just look out for the terms A and B in such a way that their product should be is equal to 5 by 6. So what can be A and B such that their product should be is equal to 5 by 6? What are the possible factors of A and B? So let us suppose we are talking about the possible factors. The possible factors of A and B, we can say, of A, B is, what are the possible factors of A and B? So we can write the possible factors are nothing but plus minus 1 by 2 can be a factor. If plus minus 1 by 2, if we'll take A as plus minus 1 by 2, then we have to take the B as nothing but 5 by 3. So plus minus 1 by 2, or we can say plus minus 1 by 3, we can say plus minus 5 by 3, and we can say plus minus 5 by 2, or let us suppose plus minus 1 we do have. They are nothing but all the factors of AB. AB's factors can be of the formation of plus minus 1 by 2, plus minus 1 by 3, plus minus 5 by 3, plus minus 5 by 2, or plus minus 1. Because if we can take the value as a half, then with respect to the half, we can take the value as 5 by 3. So half and 5 by 3 when get multiplied with each other, so it will definitely give the answer as 5 by 6. So these are all nothing but the factors of 5 by 6. Now we have to check by hit and trial method, or we can check whether these all are nothing but satisfying our given quadratic polynomial or not. Means if all these terms should satisfy this particular polynomial, then we can say that this particular term should be a factor of this quadratic polynomial. So let's see how. Let us suppose I am talking about the very first term, that is half. Let's just substitute half into this particular quadratic polynomial. So let us suppose we are taking the polynomial as, let us suppose I am calling this polynomial as nothing but p of x. So let us suppose I am calling this as p of x. I am calling it as p of x. So let's just substitute x is equal to half. Let's just substitute x is equal to half in the polynomial. So if it will satisfy, then definitely it is a factor. If it will not satisfy, it is not a factor by the factor theorem. So let's just substitute half in it. So if p of half we will substitute, it will be half whole square plus of 17 by 6 of x is half plus of 5 by c. As we can see clearly in this particular formation, all the terms are adding up to each other. So it definitely means that they won't give the answer has to be is equal to 0, because all the terms are adding. There is no such term which is cancelling out with each other. So obviously this term won't be is equal to 0. This term won't be is equal to 0. So hence half is not a factor of this particular polynomial. It means that half is neglected. So let's just talk about the other term. One by one we have to check all the factors, that are they satisfying this particular polynomial or not. So let us suppose I am taking minus of 1 by 3. So let us suppose I am taking minus of 1 by 3. Let's just check out for minus of 1 by 3. So if we'll substitute p minus of 1 by 3, it would be of the type minus of 1 by 3 whole square plus of 17 by 6 minus of 1 by 3 plus of 5 by 6. Now let's just check it out. So this will be nothing but 1 by 9. So it is 1 by 9 minus of 17 by 6 into 3 is nothing but 18 plus of 5 by 6 plus of 5 by 6. Now let's just take out the LCM of all the terms over here. We have 9, we have 18, we have 6. Let's just start with 3. So it will be 3 into 3 is 9, 3 into 6 is 18, 3 into 2 is 6. Further we can take 3, 3, 1, 3, 2 and 2 again. So 2 is 1, 1 and 1. So 3 into 3 is 9, 9 into 2 is 18. So the LCM of this particular term is definitely nothing but 18. So at the end what we are getting, 2 minus of 17 plus of 5. We have 6, 6 into 3 is 18, so 3 into 5 is nothing but 15. Obviously, we are getting the answer as 17 minus 17, which is nothing but is equal to 0. So, hence, at the end, what we have deducted, that x is equal to minus 1 by 3 is nothing but the factor of this particular polynomial. It means that we can express this polynomial in terms of x is equal to minus 1 by 3. In the same sense, or in the same way, we have to check all the factors, that is plus minus 1 by 2, plus minus 1 by 3, plus minus 5 by 3, plus minus 5 by 2 and plus minus 1, that which one of these terms are actually satisfying this particular polynomial. So in the same way, x is equal to minus of 5 by 2, x is equal to minus of 5 by 2 will also satisfy this particular polynomial p of x. So at the end, what we can say using the factor theorem, we can say that x minus of a, x minus of b, means let us suppose I am talking about x is equal to minus 1 by 3. So x plus of 1 by 3 and x plus of 5 by 2 are the factors. They are the factors of the polynomial p of x. So if they are the factors of the polynomial p of x, then in place of p of x we already have written x minus a, x minus b. It means that we can express the quadratic equation 6x square plus of 17x plus of 5 as 6 into, in place of x minus a, x minus b, what we can write? We can write x plus of 1 by 3 and x plus of 5 by 2. So this is nothing but the factors of this quadratic polynomial using the factor theorem. I definitely say that this is more lengthier method than that of the splitting the middle term. So that is why we mostly follow splitting the middle term rather than using the factor theorem, because it is quite a lengthy method in which we have to satisfy, or we have to see that whether all of these factors are satisfying this polynomial or not. So it is quite lengthy. So in place of using the factor theorem, we always used to go for splitting the middle term. Now let's just see more of the example with the help of splitting the middle term, where we can able to find the factors of the polynomial.